Hey, thanks for coming back to another Playing with Node video. I haven't got a ton of views or really any comments or anything yet on the first two, which is fine. I figure it may take a minute for people to start finding them. But what I wanted to do, instead of diving into the next piece of functionality, real quick, I just had an idea to make like something real basic, like an app or a game. And I thought, well, why not rock, paper, scissors? A lot of people are familiar with it. It's fairly easy, and I think I could knock this out in 15 minutes. So I just had this idea. I'm going to give it a shot. If it goes good, I'll post this as a third video. If not, you'll never see this. But no, I think it'll be great. It's pretty straightforward. Like I said, 15 minutes should be fine. I haven't done any prep or research on this, but I'm fairly certain it's a small lift. So yeah, I mean, let's do it. I have the code over here still. One thing I did is I added a line to the README here, linking back to the YouTube, and I'm going to try and do some pretty good documentation here for this one as well. So maybe we'll add a couple lines to the README before we're done that also documents, that you can play the game. So first thing I'm going to do is make a new folder in my examples folder called Video 3. In there, I'm going to make a file called rock, paper, scissors.javascript. I think I spelled that right. And yeah, so I could probably find a way to pull the arguments without yargs. But in the spirit of the last video modules, I wanna use that. So I'm going to do that. We have moment and short ID in the package from the last one, which is fine. We won't be using those, but we do want to use yargs. So I'm going to do a npm I or install yargs. And yargs, if you don't remember, it's just a package for getting parameters. And we'll need the documentation anyway, so I'm going to pull it up. Yeah, we did look at this before. So I'm going to let this install. That might take a second. Alright, so while that goes, we'll take a look at the documentation. It should be pretty straightforward. You pull it in like that, and then you can use it by just referencing the argument. So yeah, doing something like this, you can say, rock, paper, scissors, and then pass in what you want to throw at the computer, right? So the game will do this. You'll call the game, node space rock paper scissors.js space, and then you'll pass in what you want to play, right? Do you want to throw a rock? Do you want to throw scissors? And then the game will randomly pick one, so it'll be fair. It'll pick one at random, and then it'll make the comparison and figure out who won. Cool. So added 27 packages. 0 vulnerabilities. Okay, cool. So we got yargs version 15. Perfect. So we'll add that. Then we'll start with our module.exports. And again, there's a few ways you could structure the actual export. I didn't really dive deep into all of them, but just sticking with the standard function for now, I think is good. And because I declared this constant up here, this is scoped to this whole file, so args is available inside here. And we can prove that real quick by just only logging that. Like so. Or say you passed in, and then that. Okay, so we're seeing what we passed in here. Let's just try it. We'll run node. And we're in the examples folder, video 3, the only file, rock, paper, scissors. And it did not log anything. Oh, because I didn't call it. Ha, my fault. So we made it a function, but we never called it. There we go. Cool. And it says you pass, and then this is what the yargs object looks like. And you can see here there's an underscore property that's an empty array. $0 which I believe is just the name of the file. So it's the 0th argument, I believe. And that's it. So let's just say I did that again, but after it I said rock. Notice how rock is now in this array here, right? Oop. Go away. So now that rock is in here, right, we can access that. So I'll do dot underscore, so we're going to reference this underscore property here and see if we can get just this array to print out. And this time I'll throw out something different. I'll do paper. There you go. You passed paper. So a little bit closer now, we'll take the first element of that array. We'll do paper again. Boom, you passed paper. Cool, so now we have the input from the user. Now, I'm a big advocate for validation. You should really validate this first. So what I mean by that is do something like this, right? Say, if that element's there, then we continue. Else, right? Maybe we do something like, you did not include rock, paper, or scissors after the file name. So that's fairly descriptive enough to where someone could probably figure it out. Let's see. We'll move this up to the very top, but comment it out as we don't need it anymore. But for now, in case we do, we can uncomment it. So if they do, actually, you know, we can just put this in here. If they do pass one, we'll just see what they passed. Cool. A little bit of formatting. That's too much formatting for now. You pass paper. You do not include rock, paper, or scissors after the file name. Perfect. Maybe we'll do another log right after that. This is something like, try instead node, and then we'll give like a paper as an example. Cool. So that's hopefully descriptive enough so they can figure out how to play. Now, let's actually do the logic here. So you passed in whatever. So first thing we have to do is say let CPU choice. I'm giving the computer choice, and it needs to pick one: rock, paper, or scissors. I'm gonna just store this for I guess ease of my brain as just like a 1, 2, or 3. So I'm gonna have it pick a random number between 1 and 3. And since we didn't cover that, I'm gonna do that too. So we're gonna say node random number. And it should be math.random, yeah. So here's a good one on the Mozilla page. Personally, I always look for W3 schools if you can. I'm more used to seeing their page. But anyway, there's a lot of good places to get documentation. You can see, boom, returns a random number. We're looking for a little bit something specific. This returns a random integer from 0 to 9. And that's because the nature of math.random picks either 0, 1, or some decimal between the two. So 0 to 10 would be that times 10. So looks like we can take something like this and modify this for our use. And if you're familiar with the way arrays work, in most languages, it's usually 0 index, so they start at 0. So this is fine. So because putting a 10 here means this is 0 through 9, putting a 3 here means this is 0 through 2. So we could do a little bit of documentation, say 0 equals rock, 1 equals paper, 2 equals scissors. And there you go. So the computer now will make a choice, 0, 1, or 2 each time. So now what we need to do is we need to convert the user's choice also to a number, right? Then we can compare and contrast. Because it does us no good to compare strings to integers or integers to strings, so on and so forth. So we can say let player choice. We're not going to define it yet. We're going to do a switch. You could use a series of ifs and elses, but I think switches are neat. So we're going to switch that. And then we're going to set up some cases. So the first case is rock. In the case of rock, we're going to set player choice equal to 0. And then break. You have to break out of switches. So that's why it's like that. Oh. And then another case for paper. As you probably guessed, that's going to be player choice 1. We'll need another break, so I'll copy and paste that. And then finally, scissors for 2. And there you go. Now, you could say, well, what if they do something like rock? Right, you could handle that as well. Right, if they capitalize their first letter. And in theory, this should handle that because there's no break here. It'll keep flowing right through. Oh wait. No, it'll only flow through if that's also true. We might actually need these as well. And that's fine. And you can play with it. A little bit of experimentation. You know, try each scenario, and then you should be good. That's one of my favorite things to say is don't be afraid to break your code. You got to experiment. You got to play with it. You got to really get to know it. And that's the best way. So now we have player choice set. We have computer choice set. Let's just log these and just see. I'm running out of time here. Alright, cool. So first we're going to pass in paper. Oh, you can see the computer chose 2 that time, so that would have been scissors. They would have won. But we got undefined. So player choice became undefined. So somewhere in this process that didn't work right. It says I passed paper here. So as of right here, this was paper. Oh, because they were both capitalized. That was my fault. But it's a good lesson that you should always add a default. Right? So default means it didn't match any of these scenarios. It's kind of like the else in the situation. Maybe for now, for the default, just because we're running short on time, say something like invalid choice. You must choose rock, paper, or scissors. And then keep that same try is fine. Yeah, and normally I do like a throw or something here, but we haven't gotten to try catches. Maybe I'll introduce those in a future video. So for now, this should be fine. Let's run that same file again. And yep, there you go. So we chose 1, which is paper. That is accurate. It looks like they chose 0 that time. So now, and we're running out of time, but the last thing here is to really just replace these 2 lines and have it evaluate who won. And that is a series of if statements. All right, so we can leave these in for now while we're continuing to develop. But you could just say, first scenario is you can resolve ties real quick by just doing something like that. The game is a tie, right? If their numbers are equal, they pick the same thing. What's another scenario? Well, you could say if the player chose higher than the computer. And the way that works is paper beats rock, scissor beats paper. So the way I set this up is, if the number is higher than it, the higher number wins, unless rock and scissors is the only exception. So in most cases, this will be accurate, but we'll have to build an else if above it to mitigate that other scenario. Oops. So you could say if player is greater than computer and what, player equals 2, and computer equals 0, because if that's the case, that computer smashes scissors. So in that case, the computer beat the player. And like I said at the beginning, I didn't map this all out. I didn't plan this at all. This was kind of just like a spontaneous decision. So there could be more scenarios that I'm missing. But the only way to determine that, I guess, is to really sit down, think it through, or, play it a bunch of times and make sure it's behaving as expected. Obviously, we don't have a ton of time left, so I'm not going to do all that. But I think hopefully this was at least enough to get you to see, how this would work in theory and inspire you to start making your own. So you can see here I passed paper. He chose 0, which is rock. I should have won, and it says that I won. I play again. It's a tie. Perfect. Same thing. Just waiting for him to throw a 2. There you go. And he beat me by throwing scissors. And you can always work on the log outputs to make it, look nicer, be cleaner. And then once it is working right, so, then I check all 3 scenarios where they throw rock. The computer beat me because he had scissors. Wait, no, that's not right. Oh, there's a flip of these, isn't there? Where he's greater than me. Where I throw rock and he throws scissors. But the player still wins. Let's see, that may be it. I throw rock, he throws scissors. My rock smashes his scissors. Yep. Same. Is he really going to keep picking that? Okay, so that's a tie. So I think I throw 0, he throws 1 is the only scenario here we haven't tested. In theory, it should come up 1 and 3 times. There we go. And it says his paper beat my rock. Yeah. And if you want to, you could use some sort of switcher, nested ifs here, where you do ifs inside ifs, and come up with, what is there, 9 scenarios, right? You could have a very custom win message for each, right? Like player covers computer, or computer rock smashes player scissors, whatever that looks like. Totally possible if you have the time to do it. Hopefully this was at least inspiring or informative enough excuse me, so that you could see how you can start using randomness and some of these packages to help your development needs. One more here. Yep, so cool. And you could even very easily just do something like this, but do a switch here based on their number real quick, just to spit out the readable, friendly, nice version of what they passed. That's probably worth doing. right? Like another switch right here of computer choice. And the only scenarios really here are 0, 1, and 2. And you can say something like, the computer chose, what was 0? Rock? And maybe no default for that for now. But then at least it's a little more realistic for the player. They can say, okay, the computer chose paper. You know, they beat me. They covered me. So yeah, that's all there is to it. I know it went a little bit long. I apologize. Let me know if you thought this was helpful. Throw a comment, throw a like. If there's something else you want to see, future video. Otherwise, that's it. I think I'm signing off. Let me just go ahead and commit this for us. Make sure I have, yeah. So I'll add those to Git. Do a commit saying we created a rock, paper, scissors game in this third video. Look at that. That's a better commit message. And that's live for you. Cool. Thanks again for watching.